problem is called merge two sorted lists. We are given two heads of the two sorted links, list 1 and list 2. We have to merge two lists in one sorted list. The list should be made by splicing together the nodes of two first two lists. So we have to return the head of the merge list. We will just go through the example in details, but before we do that, let's just see what constraints we have for this problem. So the number of nodes in both lists is in the range from 0 to 50. The node values are from -100 to 100, and both list 1 and list 2 are sorted in non-decreasing order. This is probably the most important information that we have, because at the end we have to have a list that's again in a non-decreasing order. So we have to have a sorted list. To solve this problem, we will basically, because we have two lists, we will have two pointers. We'll just call them list 1 and list 2. And initially they are pointing, as we know, to the head of their corresponding list. So list 1 is pointing to the head of the list 1, list 2 pointer is pointing to the head of the list 2. Next, as always with the linked list problems, we will create our dummy pointer, which will just have like a -1 value, and it will be pointing to null. This is just to make stuff easier for us when we are dealing with the nodes. We are creating this artificial linked list node, so we can easily manipulate the list that we are given by the input for the problem. So how do we actually choose? We know that both of the lists are sorted in the non-decreasing order. How do we choose the first element? Well, basically, we will be comparing the value that currently the list 1 pointer is pointing to and list 2 pointer is pointing to. So, for example, here we have 1 and 1, and they are equal. So we can choose any list, any node from any either of the list 1 or list 2. So in this case, let's just say that we are choosing the element from the list 1. So we will basically create our current iterator, and the current iterator will be the one who will be responsible to go over the merged list. So initially it will be pointing to the same node that dummy is pointing to. There's just this artificial node. But once we choose the first element, we will use the current pointer to redirect the next relation for whatever node the current pointer is pointing to. So in this case, it's pointing to this artificial node, and we are redirecting this relationship to be pointing to the first element that we have selected. In this case, it will be the element 1. So now the dummy node is pointing to the head of the merged list. And because we have already used the first element in the first list, we can move our first pointer, to the second element of the list. And to do that, we can just basically use the next relation given by the list itself. And then before we try to select the next element, we will move our current pointer, which is just going towards into the elements. We will move it to point to the next element. And because we have already selected the next element to be the first element in the first list, now the current will be pointing to the first element of the first list. Then in the next iteration, and we are basically continuing this as long as both of the lists are valid, are having any nodes remaining. So in this case, list 2 pointer is pointing now to a node with value 1, while list 1 pointer is pointing to a node with value 2. In this case, we have 1 and 2. The node with value 1 is smaller, so our next element will basically be the first element from the second list. And to make it our next element, basically we will redirect whatever the node relationship next for the node to which current pointer is currently pointing to. So in this case, current is pointing to the first element in the first node in the first list. So we are redirecting this relationship to be pointing to the node that we have just selected. So basically, we are now the first node in the first list is pointing to the first node in the second list. And because we have selected this node, we can move our list2 to be pointing to the second element in the list, in the second list. And then before we move to the next iteration, we have to redirect our current element so we can keep on merging the two lists. And the current element will be pointing to the next element. So in this case, it's currently pointing to the first element in the first list, but we are using the next relation to redirect it to be pointing to the first element of the second list. Now we have 2 and 3. The first pointer is pointing to the element to the node with the value 2, and the second pointer is pointing to the node with value 3. Now 2 is smaller than 3, so basically we will use our current pointer to redirect this next relation to be pointing to the second, whatever the list 1 pointer is pointing to. In this case, it's the second element in the first list. So basically, the first element of the second list will be pointing to the second element on the first list because we just redirected. And again, we are changing our current to be pointing to the next element. In this case, it will be the second element of the first list. And basically so on, then we will move our list 1 pointer to the next element, which is in this case is basically the tail on the first list. So we will basically continue this process as long as we have both lists defined. So the time complexity for this problem is determined by the minimum list, the smaller list of those two, because if the first list has 3 elements and the second list has 5 elements, we are only going 3 nodes for the first list. And basically, the time complexity is determined that. What do we do with the rest of the nodes in the larger list? We already know that both lists are initially sorted. So basically, we can just merge. Let's say we have merged the first list, and the remaining of nodes in the second list, we can just use the next relationship to point to the head of the second list. In that case, we just merged those two lists. This is in the case if the 3 smallest elements are actually the elements coming from the first list. Let's say the first list contains 1, 2, 3, so the first 3 selected elements will be 1, 2, 3, and the second list might contain like 4, 5, 6, 7, for example. So in this case, we will just use this relationship here, next relationship, to point to the head of the second list. For the space complexity, because we are not creating any additional data structure, we will have constant space complexity. First, we will check if either of the two lists is an empty list, and if it is, basically we just check if that's the first one. If it is, then we just return the second list, because the only elements that the merged list will contain are the elements from the second list. Otherwise, we know that the second list is the empty one, so we just return the head of the first list. Next, we'll create our dummy node, and we will point our current pointer to the dummy node. We will iterate as long as both list 1 and list 2 iterators are inside the boundary of the lists, so they are pointing to a valid node inside corresponding list. So list 1 pointer will be pointing to the nodes in the list 1, list 2 will be pointing to the nodes in the list 2. We check first if the value that the list 1 pointer is pointing to is smaller than the value that list 2 is pointing to. In that case, we can select the element that list 1 is pointing to. So we just redirect the next relation for our current to be pointing to the head, to the current element that list 1 is pointing to. And because we have already selected that element, we can move the list 1 iterator to the next element. Otherwise, we know that the element at the list 2 is smaller than the element at list 1, or equal in this case. So we will just point our current to point to the head of the list 2, and we will, because we selected an element from the second list, we can move to the next one. So we will move our list 2 iterator to the next element. Then finally, because we are merging, we have to expect now the remainder of the merged list, so we can move our current to the next element, because we have already selected in this iteration one of the elements from either the list 1 or the list 2. So we just move the current to the current next pointer. Next, we check if we had like a larger list, if basically if list 1 is still not null or list 2 is still not null, that means that we have some like remaining nodes in one of those lists. We check if the list 1 is not empty, and if it's not, we just merge it to our merged list. And to do that, the current will be pointing to the last element of the merged list. So we can just merge the two lists by tweaking the next relation of the last element in the merged list to point to the head of the list that has still some nodes in it. It can be the list 1 or list 2. Finally, as always, we are returning the dummy next, which is basically the pointing to the head of our merged list.